So this is the final method, which is the third method that we can use to solve the problem involving the rectilinear motion, which is the constant acceleration method. Okay, which we will use the equation. We have three equations here, but the first thing to do is you must verify and check. You must verify first that the acceleration is constant. That's where constant acceleration method comes. Okay, so all these three equations can only be applied if the acceleration is constant. Okay, so if the acceleration constant, you can use these three equations, which is the first one, v equal to u plus at, v squared equal to u squared plus 2a s minus so, and we have s minus so equal to ut plus half at squared. So what is u, so, and so on? So you have u is initial velocity. So normally we will analyze this problem segment by segment. Okay, because what we have is normally we have the acceleration which is constant segment by segment. Maybe point A to B, it is constant at positive, and then it will be 0, and then it will be negative. So from we have one by one acceleration, we will analyze one by one. So u will be initial velocity, so meaning that if you analyze from point A to B, the u will be ua, v of point A, and the v is final velocity, so v will be the in this case, let's say we have from A to B, so u equal to v at point A, b and v equal to v at point B. So depend on the situation. Okay, A is a constant acceleration. Again, we highlight it is a constant acceleration, must be constant. So initial displacement, and S is final displacement, same as this one. So equal to S at point A, S equal to S at point B. Okay, final displacement T time initial to final, meaning that time taken from A to B point. Okay, so we will use this analysis, this equation for rectilinear motion. After this chapter, we will use a lot this equation during curvilinear motion. Okay, so example, we go to the example that we have from previous chapter, which is area under graph. We will use the same method, the same problem, and then we try to solve using different method, which is the first one I've shown you using area under graph. Now we will use constant acceleration method. Okay, so from previous chapter, we already calculate this one, ta equal to 5 seconds. You can look at previous example how to calculate this one. So ta equal to 5 seconds. Now first thing to do is to check a constant. Okay, to check either a is constant or not. So what we will do now is, from here we have discussed, okay, from segment O to B we have one acceleration, B to C one acceleration, and C to D another acceleration. So even though we didn't know the value of acceleration, but we can already predict this as velocity increase steadily, so we should have a constant positive acceleration, constant velocity, so acceleration will be 0, velocity decrease, acceleration will be negative constant value. So this is our prediction for acceleration. Okay, we still don't know what is the value of A1 and A2, but no, that is from A, and this is point B here. From A to B, we have one constant acceleration, which is A equal to A1, and then from B to C, this is C, this is D. From B to C, we have one more acceleration with 0. Okay, from C to D, one more acceleration, which is A2. So we have 3 constant acceleration. So what we will do, we can analyze point by point, maybe from O to B, or we can do another segment which is O to A, one segment. So OA, and then AB, and then BC, and then CD. Okay, which here we have session A1, A1, 0, A2. Okay, so we are sure that if you do segment by segment this one, our session is always constant. A1 constant at positive, and there's a 0 constant 0, and we have CD constant at negative value. So when you use this constant as a method. Okay, the first one, analyze here from segment O to A, here to A. Okay, so let's put here is I listed all the thing that I know. Okay, so O to A, U is equal to V at O. Okay, initial velocity, it is given to us -10, and then this here V equal to V at A, which is from O to A, is 0. So A equal to AOA, we didn't know. Okay, we didn't know what is the value, and we go to S. It is said that SO equal to 20, S equal to SA. We didn't know the SA. Okay, so we have two unknown here, which is SA and also OA. T between O to A is 5 seconds. It is given. We already calculate. So we have these three equation. You can choose from these three. Okay, let's say from here I've taken this first one, V equal to U plus AT, because now I already know the U, the V, and the time taken. So my only unknown is A. So from here, I've just put the info, all the thing I know, V0, which is at here. So U negative, and I put here, we can have the AO equal to 2 meter per second. Okay, so now we have the A1. Okay, so this is our A1. Okay, now we can use another equation. Now we have the A, we can put the A in another equation. Now we have A here, so we can, even though we have a lot more unknown, but now we know the A. Okay, so we can use the second equation here. Okay, V is VA, U initial VO, and plus 2A AO, we already calculate. S displacement at point A, SSO. So the only unknown here is SA, because A is already calculated 2 here. So you put all the unknown here, you can have SA equal to -5 meter. Okay, or you can use this equation, or use the last one, the other equation. You still got the same answer, SA equal to 5 meter. So you have these three equations. You can use any of these three equations, depend on your component that you know, or the unknown that you have, so that if you have one unknown, you can directly solve the problem. So you can choose. Okay, next we go to point B. Now we already know that the A right here, from here we already know A is 2, so we can directly go to AB and put the A equal to 2 from there. Okay, so AB, I can use this equation, because now the A is already known. The thing that I want to calculate now here only the displacement, because the A is already known as A, here is 2. Okay, we already calculate, so I've listed here all the information that I needed. Okay, so and then I use this equation, V equal to U squared plus 2A. So it is from A to B, so V will be VB, U will be VA, plus 2A from A to B, S the final displacement, which is SB, minus SO initial. Now we're from A to B, so initial will be VBA. And then you put the information that you have. This is 10 here, so you put 10 minus initial 0 here, 0 to 2 meter per second that we have already calculated, SB, minus this is minus 5 from our previous calculation. We have SA equal to -5. So from this one we have the SB equal to this one. Okay, this is from AB. Then we go to BC. We go to BC, where we know the A from BC, A equal to 0. So go to BC. We already know that ABC, this one, ABC equal to equal to 0. So I list down the information that I know. From B to C, U is VB, V is VC, so this is known, this is known. SO, which is initial, in this case will be SB. 20, the only unknown is C. Time taken, you can calculate from 15 to 10, so you have 5 seconds. Okay, so you can choose from these various three equation. I tried first this equation. Apparently I cannot use this equation. This one, if I put here, I get A equal to 0, but it is already 0. You don't have to calculate this one. If I try to use this one, actually you have an error, because once you have A equal to 0 here, you have VC equal to V. So because V is same here, so you cannot have any information, because we want the S. So this eliminate, so you cannot use this equation, because it will just give the statement that V at A at V equal to V at C. So nothing happens. We already know that. So we go to the last question, example, last equation, S minus SO. From here, you put the input final displacement as C, initial B, UD, U will be initial, so VB, time from A to B to C, plus this is already 0. So you put the emission, you have the SC equal to 7 meter. Okay, and then you go to last and final point, which is CD. Now we still didn't know what is the value of A. Okay, so you have to calculate the value of A, and also we didn't know the displacement at point D. So you have unknown here. Okay, other we already know. Okay, so I use this equation, V equal to this one, so V final will be D, initial is C, so because from C to D, plus A acceleration from C to D, time taken. So VD we know here 0, so I put 0. VC is 10, so I put 10 here. A I didn't know. Time taken, you 25 minus 15, you get 10. So 10 here. So you have the A, which is minus 1. Okay, so you can use A to this equation. Okay, so VD, again we have VD equal to 0. V initial, which is VC equal to 10. And then A already calculate minus here. SD minus SC, from previous calculation we have 70. Okay, we have 70 from previous calculation. So at the end, I have this as answer. Okay, so now you have all the information, the A at point from A to B, and A at CD, and you have the displacement at each and every point. Okay, see here you have the displacement SA minus 5. Okay, SB SC 70, SD 120. So you have the S at each and every point. So to answer the question, T 7 seconds, A is 2. We have calculated here. And then the question asks you to draw this graph. So you can draw, because you know all the A. Okay, and then T equal to second. What is SB? We already calculate there from 10 seconds. And then distance travel, you just put back this one. Okay, SA equal to 5, this one SB equal to 20, SC equal to 70, SD equal to 120. So you draw past 20, negative 5, and then we have 70 and 120. So you draw this path. Then you just measure from here to here, and then you get the value as this one, this distance level 25. This is 25, 2 times 25, and then plus this is 50. Okay, from 20 to 70 you have 50, and then 70 to 120 you will have another 50. Okay, so you have the distance traversed. So this is equal to 100 150 meter. So that's all. Okay, we will use again this equation when you use curvilinear motion. We will go to curvilinear motion. We will use a lot of this equation again. So you have to remember this equation. V equal to U plus AT. V squared equal to U squared plus 2a s minus so, s minus so equal to ut plus half at squared. And the way we analyze this one, we will go segment by segment, depend on the value of acceleration, which is must always be constant. Okay, that's all for this chapter. We have covered all the three method.